In this first section, we'll zoom out and build a mental model of Cosmos as an ecosystem of app-specific chains. You'll see how Cosmos SDK, CometBFT, ABCI, and ABCI++ fit together, and where your custom blockchain logic actually lives inside that stack. Cosmos is built around one big idea: the Internet of blockchains. Instead of a single global chain, many independent chains run in parallel, each with its own rules and governance. That's sovereignty. They can still talk to each other and move value through IBC. That's interoperability. And because load is spread across many chains, the ecosystem scales horizontally, instead of forcing everything through one global bottleneck. You can picture the Cosmos network as many independent blockchains, called zones, connected through a smaller number of coordination chains, called hubs. Each zone is sovereign. It has its own validators, token economics, and upgrade schedule, and it can evolve without asking permission from the rest of the ecosystem. Hubs don't control zones. They focus on efficiently routing connections and assets between zones, acting like highly reliable routers for the Interchain. The Cosmos Hub is the main coordination chain in the ecosystem. It's secured by Atom Proof of Stake, so validators bonded with Atom provide its economic security. You can think of it as a neutral routing layer for the Interchain. Zones don't need to trust each other directly. They only need to trust the hub. This enables permissionless connectivity, while each zone keeps full sovereignty over its own state, governance, and upgrade path. Inter-blockchain communication, or IBC, is how Cosmos chains talk to each other. Think of it as a standardized, secure shipping lane for packets between sovereign blockchains. It's modular. There's a minimal transport layer, and on top of it, application protocols like ICS 220 for token transfers. It's trust minimized. Chains verify each other using light clients, not custodians. Combined with fast finality consensus like CometBFT, IBC channels can be both secure and fast. When you think about a Cosmos chain, think in 3 clean layers. At the top is the application. That's your business logic, written with the Cosmos SDK. It defines accounts, modules, state transitions, fees, everything users actually care about. In the middle sits consensus, powered by CometBFT. Its job is to take candidate blocks and get validators to agree on a single final sequence, even in the presence of faults. At the bottom is networking, the peer-to-peer layer. It gossips blocks, votes, and transactions around the network without understanding their meaning. The application layer is where your business logic lives. In Cosmos, this is built with the Cosmos SDK, almost always in Go. Think of the SDK as a modular framework. You compose your chain from existing modules like bank, staking, and governance, then add your own custom modules. Together, these modules manage state, enforce rules, and expose APIs. IBCI and ABCI++ are the interfaces that let this layer talk to the underlying consensus engine. Now let's zoom in on the consensus layer and where ABCI++ sits. CometBFT is a generic Byzantine fault-tolerant engine. It proposes blocks, runs the voting protocol, and commits decisions, but it has zero knowledge of your business logic. IBCI and ABCI++ are the callback interfaces that connect this agnostic engine to your state machine. Through them, consensus asks the app, is this block valid? How should I build it? And what state should I commit? The networking layer is the transport fabric of a Cosmos chain. It discovers peers, maintains connections, and makes sure every validator sees the same transactions, blocks, and consensus messages quickly enough. Think of it as the P2P gossip engine that keeps all nodes in sync. It sits below ABCI and consensus logic, but its behavior and health directly impact throughput, latency, and ultimately the safety of the entire system. Cosmos SDK applications are built from modules, not one giant codebase. Each module owns a specific concern: accounts, bank balances, staking, IBC, or your custom logic. A module defines its own state types, messages, keeper APIs, and query or gRPC services, so you can reason about and test it in isolation. Then app.go acts like the motherboard, wiring these independent modules into a single coherent blockchain application. In Cosmos SDK, think of stores as the raw database where all on-chain state lives, and keepers as the only safe door into that database. Modules, never talk to the store directly. They call keeper methods. Those methods encode business rules, validate inputs, and enforce permissions and invariants. During deliver text, only keeper logic is allowed to mutate state, which keeps updates deterministic and protects your chain from accidental corruption. In the Cosmos SDK, everything a user wants to do starts as a message. A message is just structured intent. Mint a token, send funds, update some state. Multiple messages, plus signatures and fees, are bundled into a single transaction. Consensus only sees transactions, but your modules mostly care about the messages inside. Handlers are where messages become behavior. Each handler runs the business logic for a specific message type, updating state and emitting events. Now that we've looked at the internals of a Cosmos SDK app, let's see how the outside world actually talks to your chain. In practice, you'll use two main external interfaces. gRPC gives you strongly typed RPC methods for queries and transactions, which is ideal for backend services and tooling. REST, usually exposed via a gRPC gateway, serves HTTP and JSON, which works well for wallets, dashboards, and browser-based clients. Cosmos architecture is all about clean separation of concerns. At the bottom, CometBFT commits blocks and maintains consensus. Above that, the Cosmos SDK application layer defines your business logic using modules and keepers. IBCI and ABCI++ are the contract between those two layers. CometBFT doesn't need to understand your state machine. It just drives it via these callbacks. IBC then lets many such chains talk to each other, so each sovereign chain can specialize, yet still interoperate as if they were parts of one large modular system. Take a moment to zoom out. You now have a mental model of Cosmos sovereignty, interoperability, and modularity, and how SDK apps sit on top of CometBFT through ABCI and ABCI++. In the next module, we'll slow down again and peel apart the full ABCI++ lifecycle, focusing on how blocks are actually built.